And today we are going to talk about one other really important act, and that is called the HazCom Standard. So the HazCom Standard is one that was created far more recently than the Hazardous Substances Act, and has been modified a couple of times, most recently to align our way of labeling things to something called the Global Harmonized System, the GHS. So let's kind of start with the beginning with the HazCom Standard. HazCom Standard assures that workers know their right to what they are working with, not only in terms of the identity of the hazardous materials, but also the potential hazards associated with those materials that they might be exposed to on a regular basis, whether it's in their job, in their environment, or otherwise. The HazCom Standard also creates a series of warning labels to help identify products and issues associated with those products. So if this sounds familiar, it's because we're kind of taking some of the stuff from the Federal Hazardous Substances Act and some of the stuff from OSHA and putting it together. And this is an example of a label that meets the specifications of the HazCom Standard. So this is a warning label for 35% hydrogen peroxide. 35% hydrogen peroxide is relatively nasty stuff as far as an oxidizer is concerned. This is more than 11 times more concentrated than the hydrogen peroxide that you buy at the store. This is more than 5 times more concentrated than the stuff that you might get to bleach your hair, or you might see it used at a beauty salon. This is stuff that if it comes in contact with your skin, it will hurt you. And your warning label shows this as a result. So what we can see here in this placard, in this warning label itself, there are a couple of key areas that we want to highlight. So first of all, we see a number of different pictograms here. This one that I've outlined in blue here, these are GHS, Global Harmonized System pictograms. The one here that is outlined in dark red, this is a DOT, Department of Transportation placard. And then these last ones over here that I'm going to mark out in green, these are WHMIS symbols. Now, we're not going to spend a whole lot of time talking about WHMIS. Primary reason for them is they are not regulated or required in this country. They are not part of the global harmonized system in any way, shape, or form. However, what we'll notice is that their pictograms, the pictures that display what the hazards are very, very, very similar to the GHS pictograms, with minor exceptions. So on the label itself, we have the compound's name, hydrogen peroxide. We have some general hazard pictograms to tell us what kinds of things are capable of being seen with the use of this substance. We are told a common name for it and its concentration, in this case 35%. Anytime we have a mixture or a solution, we need to know what its concentration is as part of its labeling system. We have the trigger word danger here to indicate that we have something that is of a particular hazard, something that we definitely need to pay attention to. Underneath the word danger, we have some of the reasons why it's considered dangerous. It may intensify fire. It's an oxidizer. It is harmful if you swallow it. It will cause severe skin burns and eye damage. It may be harmful if you inhale it. It is harmful to aquatic life. So if it gets dumped down the drain or put into a river system, it can kill the fish or wildlife that are living in there. Some storage information: keep away from combustible materials, wear protective gloves and proper personal protective equipment when using it. How to use it. What are the first aid instructions? If you get it in your eyes, rinse it cautiously with water for several minutes, and then get a hold of a doctor or the poison control center. The other key thing here, and this is always an important thing to do, and you'll hear this talk in safety later, read the safety data sheet before use. Safety data sheets are part of the overall HazCom standard. You may have heard of these referred to as material safety data sheets, MSDSs. They are common packets of information about a particular chemical and what its dangers are, how to store it, how to use it. Material safety data sheets were replaced by safety data sheets probably about 7-8 years ago. There's still a lot of common language used between them. And in fact, the safety data sheet, with the exception of having a couple of extra sections in it, is almost identical to the material safety data sheets of before. And speaking of the safety data sheets, in a safety data sheet, like I said, what you have here is a packet of information about a particular chemical substance and its hazards. And there are 16 things that have to be on every single safety data sheet. Some of these things are very, very common and easy to find, easy to write. Some of them are way, 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 way more wordy. So starting at the top, a safety data sheet is going to have a chemical product name and who manufactured it. So every chemical product that is available in industry is made somewhere. The safety data sheet is going to tell you where it was made, by which manufacturer. It's also going to tell you the chemical composition and what ingredients are present. So, chemical composition, we're talking about chemical formula. We're talking potentially about, if it's a solution, what the concentration is, what its purity is, because many chemicals come in pure or impure forms. So, there's a difference between 97% purity substance and 99.9% purity substance in terms of storage, in terms of reactivity, in terms of a lot of things. Safety data sheets also include hazard identification and firefighting measures. So what particular do we need to watch out for it? How do we treat it if it catches on fire, if it is flammable? So some safety data sheets will not have much here in this firefighting measures section because they're not flammable. Other categories: accidental release measures. What happens if this stuff breaks out of its container? How do you contain it? What do you do? Who do you have to call? Where do you store it? How do you handle it? How does it go from one place to another? If I need to carry it from one room to another, is there anything I have to do in particular? If I have to take it from one floor to another, is there anything particular I have to do? I remember back in college, any time I had to take a gas cylinder from one floor to another to fill it or change it, that gas cylinder, for safety reasons, got its own personal ride in the elevator. I would literally have to wait until the elevator was empty, push the cart that held the cylinder into the elevator, push the button to send it downstairs, and it would ride all by itself down the stairs. I'd walk down the stair, down in the elevator. I'd walk down the stairs, meet it at the bottom, take it to where I needed to take it. That was a safety precaution that we used because in the event that something went wrong with the elevator or that the canister ruptured, we didn't want anyone to get hurt. And riding with a gas cylinder is a good way to get hurt, especially if something goes wrong. So, how do you do that? If I have to transport it across state lines or across country, if I have to take it out on the road, what do I do? What are some exposure controls? Are there limits to your exposure to this product? What kind of personal protective equipment do you need to wear? Do you need to wear a mask? Do you need to wear gloves? Do you need to wear full turnouts? What do you need to do? What are the physical and chemical properties of the substance? Is it a solid, liquid, or a gas? Is it a explosion risk? Is it flammable? Is it stable? Does it react with other things very easily? Is it toxic? What are some of the toxicological properties? What are the modes of entry? For some things, they're way more dangerous if you inhale them, if you can, than if you ingest them. How do you deal with that? And then the last parts, ecological information. What effect does it have on the environment if it gets out? How should you get rid of it? How should you dispose of it? How should you transport it? Again, if I have to load it into a truck, what kinds of placards need to be on the truck? What kinds of precautions do I need to take to that end? Are there any regulations regarding its use? Is there any other information that is somehow or some way important to the process? So safety data sheets are things that we can get access to relatively easily, especially now. In days of old, in order to access a safety data sheet, you would have to go to your chemical hygiene officer or whoever was in charge of safety for your particular building, your workplace, and ask to view the binder or binders that had the material safety data sheets in them. Nowadays, most of that is done electronically and cataloged electronically, and you can pretty much do just a simple search, SDS for hydrochloric acid. And what you'll find is that a lot of these come up and usually based on manufacturer. So here's the one for Fisher Scientific. See if I can get it download. There you go. Here's your safety data sheet for hydrochloric acid. And so again, look at the things that we talked about. The 16 sections are all here. Some of them larger than others, but all 16 are in fact there in this 8-page document. But you can see what are the specifics. Okay, this is what the name of the product is. Here's who made it. Here are the hazards. So hydrochloric acid is corrosive and an irritant. It might be corrosive to metals. It will cause skin burns and eye damage. It may cause respiratory irritation. If you had the unfortunate occasion to inhale hydrochloric acid by accident, if you're working with any kind of strong amount of it, it does hurt going down. Just stings the crap out of your nose. Precautionary statements. There's a signal word, so any label that for HCl needs to have the word danger on it. Any proper label would. Here are some other classifications. Again, here's the WHMIS, which again, we're not going to get into too much of those, but here's the NFPA placard for each of them. Here are your first aid measures. So if you inhale it, get to fresh air, and just kind of breathe normal, try to get the hydrochloric acid to come out naturally. If you get it on your skin, wash your skin with soap and water, and rinse for at least 15 minutes, depending upon your exposure. If you get it in your eyes, use the eye wash station, flush it with water for 15 minutes. Firefighting measures, accidental release, prevent from reaching the drains, sewer, or waterways. Handling and storage, keep it in a cool location away from foods and beverages. Do not allow it to freeze. Store away from other incompatible materials. Keep the containers tightly sealed. Must be stored in corrosion-resistant materials such as glass, polyethylene, polypropylene, these are all plastics, or carbon steel lined with rubber or ebonite. The reason for the lining there, it's a corrosive material that's going to eat through metal, so you can't store it in a metallic container of any kind. It'll eat right through it. So this is an example of a safety data sheet. And like I said, a quick internet search can pretty much get you the safety data sheet for really anything out there. Let's look at some other things as we move off of safety data sheets. Emergency action plans. Most buildings, most campuses, most workplaces have what is called an emergency action plan for a couple of purposes. One, it tells employees and employers how to deal with fires and other emergencies, how to report them properly. It also provides evacuation procedures and escape route assignments. You've probably noticed most buildings that you go into, somewhere in each building, in each hallway, you'll find one of those evacuation route kind of maps that says, here you are in the building. In the event of an emergency, the exit that you go to is down this hall over here, or down this hall over here. So in the event of an evacuation or an emergency, how do you get out of the building? And how do you do so safely? Emergency action plans can also have procedures for how to operate critical parts of the plan before evacuation. So for example, during laboratory, if we are in the lab and the fire alarm goes off, one of the things that you do before you leave the room is you turn off the gas supply to your bench before you leave. And your instructor hits the emergency cutoff button just in case some of you miss it. That is one thing that you do so that there isn't a room filling up with natural gas in the event of a fire, for obvious reasons. And there are accountability action plans in there as well. So every year, the faculty in our building here in Updike Hall have to go through safety training. And we have to sign a safety compact every year saying that we are up to date on our safety procedures and we know what we're doing. That's accountability. Also in the action plans are anything regarding rescue and medical duties, if there are any to be held in your building or by any personnel in your building, and who to contact in the event of the emergency, whether it's the building supervisor or the chemical hygiene officer or the safety coordinator, whoever that is that holds that particular title and that particular job. So we've hit on kind of the overalls as far as just broad safety measures are concerned in the workplace, the things that you need to know and that you need to be told. Now we get into the stuff where you need to learn things in terms of how to identify hazards based upon pictures, based upon placards, and that sort of thing. And so we're going to start with probably the most familiar types of placards, the ones that are the most common here in the United States. And then we're going to branch out to the most common worldwide system, the global harmonized system. So starting with what is called the DOT, the Department of Transportation symbols. You will probably recognize some of these symbols because you will see them out on the streets. You pass by a truck carrying gasoline down the highway. They're going to have a couple of these placards on them. You know, here in Vincennes, where we get 15 trains a day, at minimum, look closely on any one of the trains, you're going to see some of these placards on some of those trains as they roll through. They're common, and common for any kind of transportation. So trucks, trains, small vehicles, etc. Now, what are they trying to tell us? Well, they're trying to tell us that there's a hazardous material on board. And a hazardous material is any substance or combination of substances that has potential negative effects on health, well-being, or the environment. Those are the three things that need to be affected by the material in order for it to be classified as hazardous. It either needs to have a direct effect on your health, your well-being, or on the environment. And according to the Department of Transportation, there are 8 categories that we can classify those hazardous materials into. They are explosives, compressed gases, flammable liquids, flammable solids, oxidizers, poisons, radioactive materials, and corrosives. And so what these next slides are going to get into are what each of those placards look like so that we can help find and recognize differences between them. So let's start at the top. Explosives. Explosives are substances that will detonate when introduced to either shock or extreme heat. Inside of the class 1 explosives, there are 6 subdivisions that rank in order from low-grade explosives to high-grade explosives, and each one kind of increasing in their lethality or their danger. Explosive placards are easy to indicate, easy to look at. They are the only ones that are orange. And what I want you to pay attention to in particular is this. This is the exploding bomb pictogram. We are going to see that particular pictogram in many other kinds of systems. So the GHS uses that exploding bomb pictogram to indicate explosive materials. The WHMIS does as well. So again, that's that common thread that's running through all of them. Now, the other way to recognize explosives is by number. The class number for the material will always be found somewhere on the placard. And the reason why is because color is not always the best indicator of the class. So for example, red. Red is a placard color that we will use for anything that is flammable. But the number here at the bottom is going to help to tell us what kind of material is flammable. Is it a solid? Is it a liquid? Is it a gas? So the number does correlate here. Let's look at class 2. Class 2 are compressed gases. With compressed gases, we are looking at a number of different things that are held in gas cylinders. Now, notice that The only thing that all of these have in common is that number 2 on the bottom. That number 2 on the bottom indicates that we are dealing with a gas. The color of the pictogram gives us more information about the secondary hazards themselves. So red indicates that we have something flammable. Green indicates non-flammable. Yellow indicates something that is an oxidizer. White and black indicate something is toxic. These colors will show up in other places in other classes. Other things to look out for. This is the flame pictogram, which obviously indicates that something is flammable. This is the cylinder pictogram. And that indicates that the object is under high pressure. This is the flaming circle pictogram, which indicates an oxidizer. And this last one, the skull and crossbones, which I think everybody knows already, indicates that something is toxic. And so, again, the pictograms here I want to point out to you because, again, there's common themes. These are the things that are going to show up in the GHS system to indicate similar kinds of hazards without the colors to kind of help us along those lines. Under class 3, we have our flammable and combustible liquids. Notice again, we've got a red pictogram here, or excuse me, a red placard with the flame pictogram. The difference here is that we are dealing with number 3s here. The number 3 should indicate to us that this is a liquid. There is a difference between flammable and combustible. Flammable materials are more flammable, more dangerous, have lower flash points than combustible materials. When we talk specifically about flammable liquids later on, we'll get into what exactly those differences are, but there is a difference here in terms of danger. Class 4, these are kind of unique. We are talking about flammable solids here. Again, the number 4 here is our giveaway that we have a solid. The flame pictograms indicate that we are dealing with something flammable. But what's interesting about these in particular is that the placards themselves are different to indicate different levels of danger. So flammable solids have the red and white stripes here. So this would be any substance that under heat is going to become volatilized enough that it is able to burn with the introduction of a flame of some kind. Spontaneously combustible materials shown by the half and half pictogram here. These are more dangerous than flammable solids. These are ones that if we heat them up enough, they will actually self-ignite without the introduction of a flame or a spark. And then the third type here, these are dangerous when wet. These are substances that will and are even more dangerous in many cases, will produce either toxic gases or flammable gases that are able to self-ignite when they are exposed to water. So there are a number of materials that go in here, and they're kind of the most dangerous of the subclasses here. Class 5, we have our oxidizers. Oxidizers are things that will generate oxygen gas when they are exposed to heat, and are generally most dangerous not when they are by themselves, but when they are near flammable materials. So on their own, yes, they're dangerous. They do have some reactive power, but it's only when we put them next to something that is flammable that we really start to see a difference. There are two subclasses. The oxidizers themselves are just general kinds of oxidizers that will feed a fire. Organic peroxides are actually a little bit more dangerous because they're kind of like spontaneously combustible in a sense. Their oxidation power as they break down and decompose actually can create their own fuel. So they break down into oxygen and something that is capable of burning, and so they can end up self-igniting in the process, in addition to creating more oxygen to feed a fire. So notice here, again, the 5s here indicate that they are oxidizers, as does the flaming O, the flaming circle pictogram. Class 6, these are our poisons and toxins. These are substances that can cause relatively difficult adverse health effects, even in small doses. The primary intake methods are inhalation, absorption, and ingestion. And each of those have their own kinds of difficulties. Inhalation is probably the most dangerous of the group because when you inhale something that is of a toxic nature, it goes directly into your bloodstream through the alveoli in your lungs, and it's able to be transported to the rest of your body far more quickly than if you ingest it by it, for example. You ingest it, and it's got to go through your stomach, it's got to go through your intestines, get absorbed by the body. It can take a lot longer for an ingested toxin to kind of work its way through. Class 7, these are radioactive materials. Radioactivity, by definition, is a material that is going to spontaneously emit energy, and as it spontaneously emits energy, it usually kicks out some pretty nasty particles that can also do damage to your body as they pass through you. The trefoil symbol here, which is important, you'll find that this is, again, a common symbol for radioactivity. And again, you'll see this in the GHS system as well. And then finally, class 8 are corrosives. These are materials that are either in the solid phase or the liquid phase that will violently react with your skin or with metal. And so corrosive materials are on these black and white placards because they do cause significant damage to your skin and your organs. They are class 8. The corrosion pictogram here, you can see that it's got two symbols in it. It's got a material that is reacting with a metal bar. It also has a material that is reacting with your hands. And that is a very common symbol for a corrosive material. So again, lock that one away in your brain. You will see it again in the global harmonized system. But that's where we're going to call it a day for today. On Monday, we will finish up this chapter by talking about the NFPA 704 placard, which is the other most common kind of placarding system here in the United States. And then we will finish by talking about the global harmonized system, the GHS, which uses a lot of those same pictograms to convey various kinds of hazards in other ways.